Hello, Internet. Today I wanted to share with you a way you could make a new programming language that is kind of fun to use in, five-ish, easy-ish steps. So the first thing you got to do when you create a language, you got to decide, do you want a compiler, do you want an interpreter, or do you want something else? So I decided I wanted something else. What I really want is a VSCode extension, right? So like, if you don't have an extension, let me show you. Let me actually run my extension a little bit here. If you got no extension, you wrote your language in, you wrote an interpreter or a compiler, whatever language you want. I mean, this is your editing experience, right? Like, you're gonna have to do a whole lot of work to create an IDE, right? Why not just have the IDE be the language, right? Like, why can't the language be alive? And then, this IDE already basically has to analyze your code anyway, right? If you actually need code generation at some point, why not just have the IDE do code generation, or even do an interpreter, interpret the language in real time as you need it, right? So that was my thought. So instead of implementing a compiler or interpreter first, my language is entirely implemented as a VS Code extension. Okay, so yeah, if you want a VS Code extension, you're gonna have to set up a project, right? And if you're creating a new language, it turns out like you can do a simple thing where, like for an extension, you can just have let's see here. You can have just a package.json, specify some things you need. There's some documentation you'll read online. And then you can just specify this one file, right? You don't even need to write any code. And already you're gonna have syntax highlighting, right? So you're not going to get all of these extra little line bits that evaluate the value. That's a thing I've added. I'll get to that. But like, even without that, you're going to have all these colors, right? Which I think totally beats out this, right? If this had at least colors, it would look a little better. But just I don't know. It's just not fun, coding in an environment like that, right? Okay, so we got syntax highlighting. Next simple testable step would be to implement a lexer or a tokenizer, right? Okay, so like, what does that look like? That looks like, ooh, not this one, getting ahead of ourselves. This code right here, and we'll have tokens. So a lexer or a tokenizer is some bit of code that turns a string containing source code and breaks it up into a list of tokens or words, right? Being able to recognize that this is a keyword export, this is a function, this lex is an identifier, or, 0 here is a number, so on and so forth, right? Like that kind of thing. And we also keep track of the line number where the token appears and the column number where the token appears, right? These are useful things to know, right? So like, let's, just to be able to test this, right? I just have a little thing, tokenize GUC code, and this little bit of, this command that I added in the VS Code extension. You can just like look at all the tokens. You can check that it's what you would expect. Keyword const, identifier x, literal number 20, the equal sign. Yeah, so you can kind of look down through the code. And you can see that the tokenizer works, which is neat. Yeah. Okay, so that steps down. What's the next thing we got to do? Well, the next thing we got to do is parse the code. So yeah, the tokenizer, it is helpful, but we want some sort of tree structure that allows us to recognize what an expression is, recognize function calls, variables, variable declarations, and so on and so forth, right? That basically happens in these two files, right? It's kind of the, all of this is pretty, lots of information about, when you look up, if you've ever tried to learn how to make your own programming language, you've probably have seen this a gazillion times, the parsing and lexing. Whether you do an interpreter, a compiler, or I guess a VS Code extension, these are kind of things you've got to do. You've got to be able to analyze your code, right? You've got to be able to turn your source code into something that your machine can analyze. So, I got some basic ASTs to get started with, and then I have the parser here that will parse, a string by first turning into a set of tokens, and then converting into some structures, so, recursive descent and whatnot. So the parser is about just shy of 400 lines. If you're curious, my lexer happens to be just shy of 240 lines. So it's a little bit of code, but it's not like, it's not something you can't whip up in a day or two, I guess, if you're really into this sort of thing. Okay. Oh, and of course, right, we got to do the demo. We got to do the demo of how that works. Parse GUC code. Let's compare it with what we see here. Yeah, so as you can see, you have a declaration. Variable x is set to the number 20. You see this expression here, x plus 123. We have operation plus, and the two arguments to it are x and literal 123. And, you have something like a function. This is a variable declaration, and we're assigning it to a lambda expression, basically. The function accepts one argument, and, we have a conditional expression. So, the parser seems to work, which is good. And then we've got the annotator or codegen. So this is the part where it gets kind of interesting. This is kind of where the interpreter and compiler split off from each other, right? And also for us as well, right? It is actually a bit different. We're not going to do a straight up codegen because I actually want the language to be interactive. So annotator codegen, it gets a little bit interesting. If you're curious, you can check out my code here. But it's about 500, just under 600 lines of code. We do what's essentially you do the stuff that you would need to do in a code generation or interpreter, right? We have data structures that keep track of the variable and what kind of value it contains. An annotator will create, the annotated version of the file, right? So this is actually kind of, I feel like, the most interesting bit of an IDE for a language, implementing an IDE experience for a language. But here you have it. This is how it basically works. And then if you want to see it, I guess you kind of saw it before. You can see how it evaluates the value. It'll show you what the result of the value is. You can also give it a variable that doesn't exist. You can hover over it. It'll tell you the variable is not found. Its result is unknown. And it'll still continue, right? Yeah, I mean, this is one of the things you expect from an IDE. You hopefully, expect the IDE to recover when you have minor errors, right? Somewhere in your code. Okay, yeah. And then you get neat stuff like this. VSCode API lets you have some subset of HTML in their hovers. Turns out I can have image tags in there. So yeah, that's kind of fun. So you can play with that. This stuff. Yeah, I don't know. I just had, you can also create a map, get a key from the map, and it'll know what the value is, right? I don't know. I just thought this was fun. I know there are so many people who are interested in creating a new programming language, but I think the traditional way of doing a programming language is no fun because usually you just get something like this. You're like, aha, I have this, and then you run a command line. You run something on the command line, and then it'll execute, and you'll print hello world, which is cool. I will say, there is something fun about that. But then oftentimes, your next question is now what, right? And then you want to actually have fun programming in your language. You want to interact with your language, and you get it with any major language, right? But you just don't get it with your own language unless you essentially do a separate implementation of your language for another IDE, which I don't know, that seems a little rough to me. But yeah, that's all I wanted to share. I don't know. I thought it was neat. That's it.